guys, welcome to this video lecture series on the subject of energy technology. I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJIET Institute of Engineering and Technology. In previous video, we have seen the insulation and refractory part of the chapter of energy efficiency in thermal utilities, in which we have seen what are the different type of insulations, and we have seen the majorly asked question, that is economical thickness of insulation, and we have introduced the term of refractories. Well, if you have missed that video, you can find that video in the I button over here. So now let's start this video with the selection criteria for the refractories. Well, the selection of refractories for particular application is made with view to achieve the best performance of equipment such as furnace, kiln or boiler, and depends on their properties. So the selection criteria of particular refractories is basically fully customized thing that depends on its end use or its application. So here are some of the points that need to be considered for the selection of refractories. The first point is area of application. So where this refractory material is going to apply, that we need to consider for the selection of refractories. That means for the case of furnace, we might be requiring some other type of refractories, while for the case of boiler, we may require some other refractories. For the furnace, silica based type of refractories, that is porous in nature, are relatively used, while for the case of boiler, on the external surface we provide insulation with the glass wool material. So ultimately the application or the end use of this refractory will decide what kind of refractory we are going to use. The second criteria for the selection of this refractory is the working temperature. We have already seen different type of insulation based on the temperature range involved that they are going to apply. So the temperature range is also very important factor for the consideration of this refractory materials. So the refractory material can be used for high temperature furnaces, cannot be used for the boiler application. In the boiler, we are achieving around 100 to 130 degrees Celsius temperature, while in high temperature furnace, we are discussing about 1000 degrees Celsius of temperature, and for such high application, different type of refractories are required. Then the next one is the structural load of furnace. So the structural load of entire furnace also plays an important role for the selection of refractories. If we select refractory with the higher weight, then it will destructure the entire furnace. The next one is stress due to temperature gradient and temperature fluctuation. So while selecting refractories, we need to understand what are the temperature gradient that we are expecting from the furnace, and whether the selected material will withstand the fluctuation in temperature while running the furnace and while this furnace is off, or that is we are not using that furnace. So refractory has to play a very important role, and hence this temperature fluctuation is need to be considered while selecting refractories. The heat transfer and fuel conservation. So this refractory has to minimize the heat transfer between atmosphere and the furnace or its application, so that we can conserve our fuel and consume the less of the fuel for the production of heat energy. And the last criteria is about the cost consideration. So cost plays the ultimate role to decide the refractory materials. So these were all the important factors that we need to understand or that we need to consider before selecting the material for the refractories. Now let's move to the next point in the topic of insulation and refractories is the heat losses. So heat get lost to surrounding or atmosphere from the equipment, that is furnace or boiler. These losses we need to minimize. In furnace, heat losses from wall affects the fuel economy. These losses depend on emissivity of wall, conductivity of refracting wall and thickness. So the loss in heat is nothing but it going to affect on the fuel economy. So this losses basically depends on the emissivity, the thickness of insulation or refractories and the conductivity. Heat losses can be reduced by increasing the wall thickness or applying insulation brick. So in order to restrict this heat loss, what we can do is we can increase the thickness of insulation or we can provide refractory bricks. So for the batch operation, the heat is stored inside the refractory during the on period, and this heat gradually dissipated in the surrounding mainly through the radiation and convection during the off period of furnace. So when furnace is on or it is running, the heat energy is stored inside the refractories. So when this furnace is off, this stored heat get lost by means of convection or the radiation. The dissipation of stored heat is lost because the loss is again imparted to refractories during next on period, thus expanding fuel to generate the heat. So ultimately this heat that is lost by convection and radiation to the surrounding is need to be fulfilled or imparted again in the refractories when this refractory is on the on period. For the continuous operation of furnace, every third day practically all the heat stored in the refractory is lost. So loss with refractory will always be there, either the operation is in the batch mode or in the continuous mode. So this concludes the part of insulation and refractories in energy efficiency in thermal utilities. Now let's move to the third topic of this chapter, and that is waste heat recovery. The waste heat is that which is generated in process by combustion or chemical reaction, and then it is dumped into environment even though it could be still reused for some useful and economical purpose. So what we termed as waste heat is that the heat generated during the combustion or chemical reaction and it is directly dumped to the reservoir or environment without utilizing. Still this heat can be utilized for economical and useful purpose. So such kind of heat we termed as the waste heat. Large quantity of hot flue gases are generated in the combustor. If some of this waste heat could be recovered, a considerable amount of primary fuel could be saved, though energy lost in waste gas cannot be fully recovered. So the large amount of hot fluid are dumped into the environment and we lost this heat energy associated with such fluid. So somehow if we can recover this heat of this fluid, we can achieve significant reduction in the fuel consumption and we can increase the saving of fuel. Even though we cannot recover fully the lost energy. However, much of the heat could be recovered and loss can be minimized by adopting following measure as outlined in this chapter. So throughout this chapter we are going to see how we can recover this waste heat by different equipments. So now let's understand what is the classification of this waste heat recovery. Well, this waste heat recovery can be classified based on the temperature range as high temperature heat recovery. Following table gives the temperature of waste gases from industrial process equipment that are involved in the high temperature range, such as nickel reforming furnaces which operate at 1307 degrees Celsius to 1650 degrees Celsius. Then the glass melting furnaces, which also operate around 1000 degrees Celsius to 1500 degrees Celsius. Then we have hydrogen plants, which operate at 650 degrees Celsius to 1000 degrees Celsius. So this was the classification based on the high temperature heat recovery. We can recover heat of such high temperature, that is over 1000 degrees Celsius temperature. So now let's see the second type of classification, and that is medium temperature heat recovery. Following table gives the temperature of waste gas from the industrial process equipment in medium to high temperature range. Most of the waste heat is in this range come from the exhaust of directly fired processes. That is, process that directly utilize the fire, such as steam boiler, which has the temperature around 230 degrees Celsius to 480 degrees Celsius. Then there is catalytical cracking, which operate at 425 degrees Celsius to 650 degrees Celsius. Then we have drying and baking ovens that operate around 230 degrees Celsius to 600 degrees Celsius. Now let's see the next classification, and that is the low temperature heat recovery. Well, the following table gives the temperature of waste gas from the industrial process equipment in the low temperature range. In this range, it is usually not practical to extract work or heat. So there are some application, or there are some sources as furnace door. So door of the furnace are at around 30 to 55 degrees Celsius. Then there is air compressor. There is around temperature of 27 degrees Celsius to 50 degrees Celsius. Then some sort of the pump, they operate around 30 to 80 degrees Celsius. So practically we cannot extract heat from such sources. So they classified as the low temperature heat recoveries. We will see some of the equipment that are utilized to recover this waste heat in the next video. Till then, keep watching, keep learning. Thank you.